Assalamualaikum and hi everyone. In this video, my friend and I will talk on the topic of soil chemistry and soil management. Come with us to get more in-depth knowledge related to this topic. As we know that agriculture includes the processing of plants, animal products as well as their marketing. Most of the food and textile produced in the world are from agriculture. A subject that is familiar in agriculture is soil chemistry. To produce food and safeguard human health, soil chemistry is crucial. Studying the chemical makeup, characteristic, and reaction involving soil solid, soil water, soil air, as well as the interaction with plants and other soil organisms referred as soil chemistry. Here are a few reasons why soil chemistry is very important. We need to know how pollutant and nutrient behave in the soil system to forecast their effects on the ecosystem and develop the ways to lessen those effects. Let's move on to the historical information regarding to agriculture. In 1731, Jethro Tull, who is a farmer, inventor, writer, has created seed drill, an implement for farming that is used to sow seed orderly row on the ground. The image below shows a comparison between before and after the invention of seed drill. Before the invention, seed is cropped manually by person. As a result, unequally crops are produced. However, after the invention in 1731, the seed can be dispersed in orderly row in a field using a cow. In addition, Jethro Tull has two positive effects on the globe as a result. Firstly, by using animal like cow to hold seed drill to disperse seed orderly row in a field, it reduces the consumption of earth and energy and manual labor necessary to plant crops. Secondly, by reducing time consumption and also improving the productivity, it can increase the amount of food that farmers can produce in one time. Moreover, Jethro Tull also published treatise entitled Horse Hoeing Husbandry that focusing on principle of vegetation and tillage. It is designed to introduce new method of culture. This method teach on how to increase land production and reduce or decrease the usual expenses. Macronutrient vs micronutrient. Macronutrient is the nutrient that plant need in a large amount, while micronutrient is the nutrient that plant need in a small amount. For example, carbon, hydrogen, oxygen, nitrogen, phosphorus, sulfur, calcium, and also potassium is the nutrient that plant get from the soil, while carbon, hydrogen, oxygen is the nutrient that plant get from air and also water. For micronutrient, for example, iron, zinc, boron. Additional information, higher tree need nutrients like silicon, cobalt, selenium, sodium to grow up.
Now, we will talk about the iron. Iron is the element that involved in various soil chemicals. Iron is a charged molecule. There are two types of iron. Firstly is cation and secondly is anion. So, what is cation? Cation are positively charged ion. Cation are the key component cation exchange capacity and important key of soil. Potassium, calcium, and magnesium ion are the major plant nutrients that occur as positively charged ion that can be held negatively charged group on particles of mineral and organic matter and released relatively easily for uptake by the plant. So next, what is anion? Anion is a negatively charged ion. Common soil anion are chlorine, nitrate, sulfates, and phosphates. Note also that anion can have more than one negative ion charge and may be combination of elements with oxygen. Next, we will talk about the soil colloid. When we talk about the soil colloid, what is colloid? The colloidal states refer to a two-phase system in which one material in a very finely divided state is dispersed through second phase. As example, solid in liquid, like we see like a dispersion of clay in water, and the next example like a liquid in gas, as we can see cloud in atmosphere. Colloids are the most active constituent of the soil and it determines the physical and chemical properties of the soil. The soil colloidal fraction is defined as that fraction of the soil made up collectively of small inorganic and organic particles. The high specific surface area and the presence of electric charge on most particles are responsibility for the important soil characteristics such as swelling capacity, the ability of the soil to retain water, the cation and anion absorption, and ion exchange. Before we talk about the soil colloid, now we will talk about how soil colloids are formed. Okay, first, as the soil formed during the weathering process, some mineral and organic matter are broken down to extremely small particles. After that, the chemical change further reduce the particle until they cannot be seen with the naked eye, which is the fine particle. After that, the very small particles are what we call the soil colloid. This is how the soil colloids are formed. Now, we talk about the type of the soil colloid. There are 4 types of the soil colloid. The first one is layer silicate clay. The second one is olefin. The third one is iron. The fourth one is humus. Among the 4 types of the soil colloid, all the soil colloid is inorganic colloids except humus. Humus is the organic colloids. So now we will go to the first type, is the layer silicate clay. So the layer silicate clay are the most important silicate known as phyllosilicates, lifelike. They comprise of the 2 kinds of horizontal sheets, one dominated by silicon and other by the aluminium magnesium. So the second type of the soil colloid is the olefin and associated amorphous clay. Like example, olefin or ammoglite. So they are the amorphous in nature. These clay are common in soil forming from volcanic ash like the olefin. These clay have the high anion exchange capacity or even high cation exchange capacity. The third type of the soil colloid is the iron and aluminium oxide clay. Under the condition of extensive leaching by the rainfall and long-time intensive weathering of mineral in humid warm climate, which have the lower solubility, are called sesquioxide. Sesquioxide, which is known as metal oxide, are the mixture of the aluminium hydroxide, which is the LlOH3, and iron oxide, which is Fe2O3, or the iron hydroxide. The last type of soil colloid is humus. Humus is the only one which is the organic colloid. Humus is the from dark brown to black, nearly insoluble in water but more insoluble in dilute alkali, as example NaOH, KOH solutions. It consists of various chain loops of linked carbon atoms. Humus is temporary intermediate product left after considerable decompositions of plant and animal remains. Humus contain partially dissociated analyte, carbonyl and phenolic group.
Okay, next we move to the CEC, which is cation exchange capacity, which is important to soil and soil management. Okay, CEC is a measure of the soil ability to hold cation such as magnesium, natrium, and calcium by electrostatic force. And for information, most clay and organic matter water is negatively charged, which is it can hold the cation. Okay, high CEC will have a greater water holding capacity, which is important to any plant. And soil CEC will increase if the amount of clay and organic matter increase and soil pH increase. And this cation will help by the particle of clay and humus, or we call it as a colloid, which is a storehouse of nutrient for plant roots. And high colloid negative charge will have a greater capacity to hold and exchange cation, which is cation are the important nutrients for any plant. So as you can see in this picture, this is show how CEC happen in a soil. As you can see, the anion will attract the cation, which is the nutrient for the plant, and more clay will more help the cation. And if the soil have a low CEC, we can improve the CEC, such as we can add the lime and raising the pH.
Next, we will go to the pH and how can we modify the pH soil. Okay, firstly, we will know what is the pH soil. Soil pH, or the pH soil, is a measure of the acidity or alkalinity in the soil. Mostly pH in the soil in the acidic to the natural range, which is between the 3.5 to the 10. However, in the rainy location, it's tended to acidic and more than to the neutral. And however, in the rest area, it's more tended to the alkaline range. This is because the water in the rainy areas leach basic ion like calcium, magnesium, and potassium, and replace them with acidic ion like hydrogen and aluminium. While the dry area more alkaline because they contain lime or sodium in high quantities. In the dry region, moisture in the soil with dissolved alkaline is brought to the surface and the water evaporates, leaving the alkaline material near or at the surface. Here are some factors that influence the pH soil. The firstly is the erosion of the native rocks. The next one is the decomposing of organic material. The third one is the physical surrounding, and the lastly is the climate or the weather of the certain area. Now we want to know why the soil really have to be in the neutral region. Okay, this is because in the neutral region, mostly of the nutrient have in the neutral region, while for the acidic region, it will have low content of the major nutrient that will stand the growth of plant, while for the alkaline region, it will have the low content of the trace element that can also stand the growth of plant. And as can we see from the picture that at the neutral region, it have many nutrients that can help the plant grow. It is like you can see some sign at your plant that can help you to detect that the soil condition, whether it in the acidic range or the neutral range or the alkaline range. Okay, for the line bar at the slide, the number 1 is for the acidic range, the number 7 is the neutral range, while the number 14 is the alkaline range. Okay, for the acidic range, we will see at your plant, it has the leaf blight, the stunned or twisted leaf, and the leaf taper. While for the alkaline part, it will show that it has yellowing of lawn for stem development and the spot of leaf necrosis. Okay. And all of this because of when the soil pH is too high, it can pose problem for plant health and growth. For many plants, soil is high in alkalinity, make it harder for plants to drink nutrients from the soil, which can limit their optimal growth. Acidity has the following effect on the soil. Firstly, it will decrease the availability of the plant nutrients such as phosphorus, molybdenum, and it also increases the availability of some elements to the toxic level. For example, the aluminium and the manganese. Highly acidic soil also can inhibit the survival of the useful bacteria. We have no effect of the acidic soil and the alkaline soil. Now, at that stage, we want to know how can we modify our pH soil. Okay, at the left side, which is how can we down the pH, or we want to become the soil more acidic. Okay, firstly, we use the organic material such as the compost. This is because the compost have positively charged hydrogen ion. Then, when it released to the alkaline soil, it will lower the pH. As we know, the lower pH is the acidic state or reagent. Okay, the next one is the add sulfur to soil. This is because the element sulfur into the soil will produce two hydrogen ion. This hydrogen ion release cause the soil pH to decrease. As we all know also, that the acidic has the more hydrogen ion. So if we have more hydrogen ion, so the soil become more acidic. And then lastly, the aluminum sulfate. In the aluminum sulfate, it has two factors that help to decrease the soil pH. The first one is the sulfate, as stated before, and the third one is the aluminium. Aluminium produces the acidity as soon as it dissolves in the soil. For the right one is the how can we alkaline the acidic soil. The first one is by using the liming material. Okay, why we use the liming material? This is because the lime will neutralize the acidity by dissolve and release a base into the soil solution that react with the acidic component. The second one, we will use the wood ash or the burnt wood. Okay, the burnt wood has produced many carbonate, high amount of carbonate. So this carbonate help to react and neutralize the acid in the soil and causing the pH to increase. And then lastly is the use of baking soda. As we all know that baking soda is the alkaline material. So by dissolving it into the soil, it will help to the increase of the soil pH. Okay, this is the hydrangea species. The special of this species that it can grow with variation of the soil pH. As you can see from the picture that in the acidic range, the flowers will blue in color, while in the neutral state it will be in color. So maybe if we can have this plant at a certain place, so it also can help us to detect that the soil pH in the white reagent. For the DIY time, we will see a video in the next slide that can help you to test your soil pH at your home.
Soil pH is one of the most important parameters for plant success. Fall too far outside of that acceptable range, and your plants are going to suffer and underperform at best. And at worst, they'll just simply perish. That's why being able to quickly test your soil on the fly is very, very useful. Hi, I'm Jeff from the Ripe Tomato Farms. Welcome to another episode of the Garden Quickie, the show where in 2 minutes or less, being useful is our specialty. And today's episode is all about that soil pH. Specifically though, how to test your soil quickly and cheaply with just 2 household ingredients. Time short as it always is, so let's dive in. To start, collect 2 equal samples, about a cup's worth each, from the soil you want to test. If it's a really large bed or plot of land and you believe you got some hot spots, you can collect soil from different areas. Or you can combine the soil for an overall measurement. With our soil samples collected, let's test for alkalinity or high pH first. Both the acidity and alkalinity tests work because of the principal reaction that acids and bases have when they meet. Remember back from grade school science that when an acid comes in contact with an alkaline or basic substance, bubbles form. These bubbles are in fact carbon dioxide being released from the relatively violent reaction. Therefore, all we need to do is add a sufficient amount of acid, in our case some vinegar, to that soil and watch for bubbles. If you see bubbles forming and it happens almost immediately, then you have a soil with a pH that is alkaline or greater than 7. Now, if there's no bubbles, like I'm seeing here, then we know that the soil is either neutral or already acidic. So, that's great, on to the next test. For acidity, this is where our baking soda comes in. But first, we need to liquefy the soil by adding a sufficient amount of neutral water. Usually around 50% of the volume of the soil that you're testing works great. In this case, we got a cup of soil, so half a cup of water should suffice. A nice good soupy mixture is what we're after. Now, add a single heaping tablespoon of baking soda and watch for action. If the solution bubbles, then we know that we have a soil with a pH below that neutral line of 7. If nothing happens and we didn't already do that first test, then we'd have to assume that this soil is either neutral at 7 pH or already alkaline. So, it's only by combining the 2 tests together that we know whether or not we have an acidic or an alkaline soil. Both tests need to be done simultaneously to be able to rule the other one out. Now, these tests won't give you the exact part of the 14-point pH scale unless in fact your soil is neutral. Then you know it's 7. But it'll give you an idea of where your soil is at on the spectrum, which is massively beneficial to any grower. Know what else is massively beneficial to any grower? Checking out the next episode of the Garden Quickie. Thanks for watching, guys. And hey, if Garden Quickies are your thing, be sure to click on this playlist here as we explore and solve more growing issues in 2 minutes or less.